Whenever a client communicates with a server using HTTP, one of the information the server needs to know is the client's intention for calling on the server. Hi, this is FK, and welcome to another fundamentals video where we'll be taking a tour into the world of HTTP methods. If you have ever instructed a client application to make a HTTP request to a server, you definitely must have come across these terms: get, post, probably put, maybe options, or even the rarely used patch. These terms are known as HTTP methods. So what is an HTTP method? Great question. In this video, we'll be walking our way to understanding what an HTTP method is really all about. HTTP is a type of communication between entities on the internet. And just like regular communication, every statement you make has an underlying intention. Whether you're communicating with your boss to request a leave, with your friends about the last football game, or even with your neighbors about the weather, each type of communication has an intention, uses a certain style, and expects a specific result. This is the same with HTTP communication. So, think of HTTP methods as a way to convey the intention of your communication with a server. The specified intention, or in this case, the HTTP method, defines the type, style, and expectations of the client's communication with the server. For example, a client request that uses a GET method intends to retrieve information from the server, and thus always expects a full and clear response. Meanwhile, a request that uses a POST method intends to store a piece of information on the server and is fine with just getting a simple OK, indicating that the information has been successfully stored. In this video, we'll be looking at and breaking down all the available HTTP methods in the standard definition. I intentionally specified that we will be looking at methods in the standard definition because there are also a bunch of methods not defined in the formal specification. But more on that later. To fully grasp each method we'll be looking at in this video, we'll also be describing them using a standard set of attributes. Think of it as more like a checklist of supported features. The first attribute is the requirement of a request body. Some methods require you to send a body of data in the request. Some don't, and some really don't care what you do with that section. Second attribute: does the response contain a body? Some HTTP methods' response do not make sense without a body, while it is optional for others. Third attribute: is the request method safe? What does safe even mean in this context? A request method is said to be safe if the request does not change anything on the server. A GET method is safe as it only requests information, whereas a POST method is unsafe as it intends to add new information on the server. Fourth attribute: is the request method idempotent? Okay, now, what the freaking frack is idempotent? Simply put, an idempotent request method is one that has no side effects. What this means is that if the request is duplicated, mostly out of error, it will not have adverse effects on the expected state of the server. Fifth attribute: is the response from using the method cacheable? A cacheable response is one that can be stored by the client for a time period. During this time period, the client can always get the saved resource from the store instead of having to make new requests to the server for that same resource. And finally, the sixth attribute, which is support for the request method in an HTML form. This tells us if the request method can be used directly in the method attribute of an HTML form tag. So now that we have our features defined, let's take a look at each HTTP method. starting with the most used HTTP method, GET. The GET method couldn't have been more perfectly named. This HTTP request method simply tells a server to send a resource. This resource can be plain text, an HTML page, an image, or even a PDF document. To get a little nerdy, what a GET method is actually requesting is a representation of the requested resource. Every resource you request will actually be sent in a format that can travel in the body of an HTTP message. So, your HTML page will most likely not come as a file, but as text. And with the correct content type header set, your browser will be able to parse and display it as a standard web page. To send a GET request, all you need to do is to point at the URL of the resource you're requesting, along with some optional query parameters. The server will then respond with the resource and a standard 200 OK status code to tell you that the request was successful. Now that we understand what the GET method is all about, let's look at how it stands on our feature list. Does it include a body in the request? The answer to that is no. And some servers will return a client error if you include a request body. If you wish to pass any type of data to a GET request, use query parameters. Next, does it have a body of response? Yes, it definitely does. And this is the whole point of requesting a resource from the server. Is it a safe request method? Yes, it is. Requesting a resource doesn't change anything on the server. Is it idempotent? Absolutely. Even when you request a resource multiple times, it doesn't have adverse effects on its expected state. Is it cacheable? Of course. The client can always cache the response within its specified cache limit. And finally, can it be used in HTML forms? 1,000 yeses. It's so supported on HTML forms, it's almost the default. According to the HTTP 1.1 specification, it is mandatory for all HTTP servers to implement the GET method. So, that's the GET method. Now let's move to the next method on the list, the head method. The head request method is quite interesting as it functions exactly like the GET method with one major distinction. It gets the exact response as the GET method, everything except the actual resource being requested. Yup, you had that right. The head method gets all the headers that you will get if you were to use a GET method, but excludes the body part. This allows HTTP clients to inspect the resource without actually downloading it. You can get useful information about the resource, like its content type, the language it is returned in, and the size, to know if your client is capable of handling the resource. It can also help you know if the resource actually exists by looking at the status code, or if it has been modified by looking at the response headers. Server developers must ensure that the headers returned are exactly those that a GET request would also return. On our feature list, the head method is also pretty similar to the GET method, with two major deviations. First, it has no body of response, just like we described. It is simply for diagnostic operations. And second, it is not allowed for use in an HTML form. Just like GET, the HTTP 1.1 specification also made it mandatory for all HTTP servers to support the head method. Now that we have a good understanding of head, let's move to the next HTTP method, and that will be the post method. Hello guys, this is FK, and honestly I am tired of all the debates and arguments I'm seeing on Twitter and Reddit about which programming language is better or which framework is better. While many developers are still lacking in the understanding of how programming languages work, how databases work, how web servers work, and how even software systems work. Lack of understanding of these main fundamentals has been the reason for things like imposter syndrome, not knowing whether you're programming the right way, or even struggling to try to be a senior developer. So, I have taken it upon myself to teach these core fundamental topics. These topics never change, and they form the bedrock of any proficient developer, DevOps, cloud, or blockchain engineer. So, if you want to get free materials and videos sent to you every week, use the link below to join our fundamentals community. I can't wait to share exciting software fundamental lectures with you as we all strive to become better software engineers.
The POST method was designed to send data to the server. The data transferred to the server can then be transported to some other place, like a gateway program such as a PHP script, or transformed into some other form or formats, or even saved in a repository like a database system. POST requests are often seen used in HTML forms to deliver data entered into the form to the web server. Data sent by using a POST request is conveyed in the body section of the HTTP message and is often referred to as the payload, a term derived from the definition of every other load carried by a transport system: vehicles, aircrafts, ships, and many more, which does not include what is necessary for its operation. Just as passengers and luggage are considered payload on an airplane, the data carried by HTTP request messages in the body of the message are the payload. This data is encoded to ensure that it is transmitted safely and accurately. The most used encoding schemes for transporting data include X, www, form URL encoded. This is the default encoding scheme used by browsers to submit form data. The format for this encoding has the data arranged as key value pairs separated by ampersands. Each key value pair is then URL encoded to replace special characters like the pound, percentage, and question mark symbols with their corresponding escape sequences. For example, %20 is used to replace any white space in the data being sent. Another encoding scheme is multipart form data. This is used for sending files and binary data by dividing the data into parts, hence the name multipart. Each part of the divided data represents a different field or file and has a boundary delimiter and a content type specified for each part. The next encoding format is the application JSON format, and as you may have guessed, this is for sending structured data in the JSON format. The text plain encoding format also helps to send data in plain text without any specific encoding. And lastly, we have application XWWW form URL encoded. This is used for sending files along with the form data without the multipart form data boundary. This is achieved by sending the file data as a base64 encoded string, which is then included in the form data. Now that you understand how the POST method sends data, let's look at how the method stands on our methods attribute table. The POST request definitely has a request body, as this is the data it will send to the server. A successful response from a POST request is also required by design to have a body. Is a POST request safe? Nah. As an operation that leads to a change on the server, typically creating a new record, the POST method is not a safe method. The POST method is also not idempotent. calling the same POST request multiple times will most likely have side effects on the server side. For example, it can lead to the duplication of transaction records, which is something I have had personal experience with in my dark days of being a novice in system design. Is the response from a POST request cacheable? Yes, it is, but only if caching information is returned through headers like cache control and expires. Do note, however, that caching POST requests is not a typical activity and can lead to unexpected behaviors. GET requests are more suitable for caching operations. Finally, are POST methods supported in HTML forms? Oh yeah! POST methods are the kings of HTML forms. You can even make an argument that HTML forms were specifically created for POST requests. I must admit, that was a lot of information on the POST method. But don't worry, we'll be moving to our next method, the PUT method. The PUT method was designed to be the inverse of the GET method. A GET method requests information, a PUT method writes information. Now you may be asking, isn't this the same thing a POST method does? In a way, yes, but no. To clear up any confusion, let's take a look at how PUT works. The strategy of the PUT method is this. Take the body of the request and use it to create a new document specified by the URL. If the document already exists, use the data in the body of the request to replace it completely. This is why PUT has been mostly used today for update operations. A POST request method aims to and will create new data each time it is made, while a PUT request can recognize an entity that already exists and update it, instead of creating a duplicate. The PUT method can also use the encoding types used by the POST method. Encoding types in HTTP requests depend primarily on the nature of data being sent and not the HTTP method. To further understand the PUT method and how it differs from the POST method, let's take a look at PUT on our methods table. PUT has a request body for sure. This is where the data being transmitted is stored. A PUT request may or may not contain a response body in a successful transaction. Is PUT safe? Nope, it's so not. A PUT request will lead to a change on your server. Is it idempotent? Definitely. However, this is something programmers have to keep in mind to implement. An update operation that changes, let's say, my name from FK to DJ is idempotent. No matter how many times it runs, it will produce the same results. However, a PUT request that increments an existing value by, let's say, 5 is not idempotent. Anytime it runs, there is a new total. Thus, developers need to ensure that they develop their update request handlers to be idempotent. A PUT request is not idempotent by just saying it is. Now to caching. PUT requests responses are not expected to be cached. And lastly, PUT methods are not allowed for use in HTML forms. That's all on PUT. Now let's go to our next request method, the options method. The options method gives client applications the ability to inquire about a server before accessing it. This is similar to calling the front desk of a hotel to inquire about their rooms and facilities before making a booking. The client can ask what methods the HTTP server supports, or even ask if the request will succeed when making a request to a different domain than the one hosting the client. An operation known as a CORS preflighted request. These inquiries can be made using the options method at both the server level and the resource level. Some servers may support particular operations only on particular kinds of resource objects. One of the most interesting parts in the response to an options request is the allow header. This header contains the list of supported methods on the server. It can also be broken down to separate allow headers, each specifying a category of allowed functions. Now that we understand how options work, let's take a look at it on our methods table. An options request has no request body. You don't need to send any payload to the server you are inquiring about. The response may or may not also contain a body. Is it safe? Very much. There are no changes made to the server you are inquiring about. An options request is also idempotent. You can make the request over and over without any adverse effects on the server. The results are not cacheable, as it mostly doesn't even contain a body of response. The method cannot also be used in an HTML form. And that's all on the options method. And at this point, we'll be taking a break from this topic to continue in another video. The purpose of these videos are not to overload you with information, but to help you attain in-depth understanding of day-to-day technical concepts. So, we have decided to break this video into two parts. And in the next part, which we will be uploading after this one, we'll be covering the following methods: connect, patch, trace, and delete. You definitely don't want to miss that. So, I advise that you subscribe to our channel and keep the notification button on so you can get notified immediately we drop videos. Till I see you again in another video, go be the best you can be.